we're going to discuss the working set cal. Now the working set cal is a utility that's written in BridgeWorks in the plugins, and this plugin essentially allows you to calibrate the known resistance values against primary reference standards. The known resistance standard, which is your working set, is kept in the top bay here in your rack, and consists of the 1 ohm all the way up to 10 meg and a 0.1 ohm on the end. And this bank of resistors is calibrated against a set of primary references, which is sitting over here. We have a 6634TS here. You may have different types of traveling standards as well, but they usually consist of a 1 ohm, a 10K, a 1 meg, and a 100 meg. And we usually connect them. It's kind of a standardized setup, and you'll see this in the utility window where you have your references, 1 ohm reference is on 13, your 10K reference, primary standards on channel 14, your 1 meg is on channel 15, and your 100 meg is sitting on channel 16. And to launch the utility, you basically go to the BridgeWorks plugin menu over here, and you find working set cal on the list. The working set cal is a window basically where it's asking you to submit a bunch of different data. And so for the working set cal, you would use the load button next to the channel to load the corresponding resistor profile. To load the resistor profiles, essentially you will see a load button here next to the corresponding channel assignment. And so the ones here indicated in red are for your primary references that are connected to channels 13, 14, 15, and 16. So you click on the load button, and you'll navigate to where your resistors are stored, and I will load my 1 ohm reference into that channel, and continue to do this for the rest of your resistors. 10K reference, looking for my 1 meg reference, and so on and so forth, 100 meg. Now you have to load the resistor profiles for the working set as well, and the importance of loading the ones for the working set is that the working set, these are actual resistors that are sitting in your rack. So you want to make sure that you're allocating those directly, because you're actually going to be able to update the values stored right in the profiles for the resistor after the test is done and you've accepted the results. Once this is in place, the test will actually run for approximately about 24 hours and calibrate all the resistors in your rack. So I finished loading all the channels and the assignments that are here, and so this thing is ready to operate. Over to the side here, you can express your cal interval, which is typically 12 months. Most people will do their calibration on an annual basis. And again, a good practice is using the preview option inside this window, which shortens all the tests down to about 10 samples and runs the bridge at an accelerated reversal rate, just to keep the system running really fast, but to make sure that the thing can actually make the measurements and that there's no problems with your wirings and that sort of thing. And it's a good practice. Takes maybe half an hour to an hour. So again, this process would run overnight, and you would use the preview maybe an hour before the day is out, just to be sure that it's operating, and you know it's going to take place overnight. You're not going to have a morning where you have no results, and then you take the preview off and just click on start. And it's going to ask you where you would want to store all of your data, because this will actually log all the test files out of there. So you pick a directory and hit OK, and the test will carry on from there. And all the data will be stored directly into the folder that was just created, and you can review that at any time. So when the test is complete, you're going to basically want to review the results. And again, like the verification utility described earlier, just click on the report button, and you can choose to view the current file or previous data from a working set run in the past. And what will happen here is you'll be greeted here with a window essentially that shows the new calculated values for the set of resistors up here in the rack. And these values are calculated against the known primary values that were connected. And this is essentially a traveling standard that would go from your base to the primary base or even a national lab. And essentially what happens here is you have your value and your associated uncertainty, and as you scroll down, you'll see here there's a section called closures. And what the closures does is it just kind of looks at your calibrated value, for example, of your 1 ohm, and then the calibrated value of your 10 ohm. And as you ladder up with the bridge, you're measuring 1 ohm to 10 ohm, then 10 ohm to 100 ohm, 100 ohm to 1K, and then 1K against the 10K. As you ladder up, you'd expect to basically make it from the 1 ohm to the 10K and realize the same value at 10K, counting up from all the ratio steps at 1 ohm. So it kind of checks those things and just make sure that as you're making these steps, that the laddering makes sense with the uncertainty budgets that are prescribed for each of the resistors. So it does this from the 1 ohm to the 10K, then the 10K to the 1 meg, and then the 1 meg to the 100 meg. It checks all these ladders, and also checks the interchanges at 1 ohm, 10K, and at 1 meg, just to make sure that the ratios are making sense and the bridge is actually still measuring within what we'd expect to be its full rated accuracy as well. So it's kind of an integrity check. And so you want to pay attention to that as well too, because that will be the basis for you to decide whether or not you wish to utilize these values as your next set of calibrated values on your standard. And that being said, right up here, you see there's a set of checkboxes right beside all the resistor files. Now these were the files that I had loaded, as you can see here, in the working set window. These files here, if I click on the update file button here, what it'll do is it'll take these new values and it will actually install that value and a new calibration date right inside the resistor profile. So now when you go to use those resistor profiles, the new value that's been assigned to them will be the value that's used for BridgeWorks throughout the entire program, anytime you ever pull up those files and use them. And essentially that's how the working set utility works.